interpolation and extrapolation. Here I will take example first. Here x and here f of x, that means y is equal to f of x. So x values, some x values they given. So for 0 it is 6 and for 4 it is 15 and for 5 it is 17 and for 8 here it is 29 and for 10 it is 40. So here I called this one as x naught and last term as xn. First term as x naught and last term as xn. Now what is interpolation means? Here the process of finding the values of y for any values of x between x naught and xn. Here suppose if they ask to find out f of 1, f of 2, here f of 3 or f of 4.5 or here f of 6. Here these all values are in between x naught and xn. So these are called interpolation. Now here suppose if they ask to find out minus 0.5, f of minus 0.6, f of minus 1 or here f of 11 or f of 12, f of 13. They ask to find out here outside the range of x, so these are all called extrapolation. So now I'll go for the definition. Here if y0, y1, y2 so on up to yn be a set of values of an unknown function y equals f of x corresponding to the values of x from x0, x1, x2 so on up to xn. First of the process of finding or estimating the values of y, this one values of y for any values of x, it should be between x0 and xn. Is called is called interpolation. Next, here the process of estimating or finding the values of y outside the given range of where it is x, outside the given range of x is called extrapolation. So they'll ask for 1 marks question, what is interpolation and extrapolation. Remember this one. Now interpolation for equal intervals. Interpolation for equal intervals. Here there are 3. First one, here Newton, Gregory, forward interpolation formula. Short form is NFIF. Second, Newton, Gregory, backward interpolation for interpolation formula. Short form is NPIF. And last one is central difference. So here I will talk about central difference last. Okay, so first I will take forward and backward differences. Newton-Gregory forward interpolation formula and Newton-Gregory backward interpolation formula. So I will talk about central difference later. Now here first one, Newton, Gregory, forward interpolation formula. Here interpolation for equal intervals means here we give the x values, these differences all should be same. If you get here, so that means x values here they given 0, 2, 4, 6, 8. So 2 minus 0 will get 2, 4 minus 2 also difference 2, and 6 minus 4 is also difference 2, 8 minus 6 difference is 2. So this difference are equal, then you will go for equal intervals. Then you can go for Newton-Gregory forward interpolation formula or Newton-Gregory backward interpolation formula. Central difference also you can go. So it should be an difference should be same, remember that one. So here now the value of the values of y equals f of x at x equals x naught plus r into h, r into h, that is y suffix r equals f of x naught plus r into h is approximately given by here y equals f of x equals y naught plus r into delta y naught plus r into r minus 1 divided by 2 factorial into delta square y naught plus r into r minus 1 into r minus 2 divided by 3 factorial into delta q y naught plus so on plus r into r minus 1 into r minus 2 so on r minus n minus 1 whole divided by n factorial into delta to the power of n y naught, where r equals x minus x naught divided by h. Now second one, Newton-Gregory backward interpolation formula. The value of y equals f of x at x equals xn plus r into h, that is here, that is y suffix r equals f x means you have to substitute this one, so xn plus r into h is approximately given by y equals f of x equals here y suffix n plus r into del y suffix n plus r into r plus 1 divided by 2 factorial. In forward r minus 1, here will get r plus 1. So del square y suffix n plus r into r plus 1 into r plus 2 divided by 3 factorial into del q y suffix n plus so on plus r into r plus 1 into r plus 2 r plus 3 so on r plus n minus 1 whole divided by n factorial into del to the power of n y suffix n, where r equals x minus xn divided by h. So we have to remember these two formulas is very important. So when you apply forward formula and when you apply backward formula, so here appropriate interpolation formula. So here for interpolation or extrapolation, Newton and backward formulas are same. Remember that one. So here I will take example x here. For 0 y equals f of x, here it is 2, and for 2 it is 4, and for 4 it is 6, and for 6 it is 8, and for 8 it is 10. So here first you have to remember when you apply for Newton forward and backward formula, x values should be equidistant. Equidistant means difference always must be equal. Which are the difference? 2 minus 0, difference is 2, 4 minus 2, difference is 2, 6 minus 4, it is difference is 2, and 8 minus 6, difference is 2. So all difference are equal, then you can apply Newton forward or Newton backward. Now when you will apply forward formula and when you will apply backward formula, so here first they given the data, right? So first you have to find out the first half of the table, middle value. You have to find out the middle value. So in middle value, whatever the upper values will get here, suppose they ask to find out f of 2.5, f of 2.2, f of 1.5 or f of 0.5. So here this is x0 and I will call it this one xn. So all values are in the upper part of the table, first half of the table. This is first half of the table, and see this second half of the table. So these values are in the first half of the table, so it is near to x0 value and it is nearer to x0 value. So you have to apply Newton forward, Newton forward formula. Remember that one. So here suppose if they ask to find out 4.5, f of 7.5 or f of 7. So here these values are you get second half of the table and is nearer to xn values. Here 4.5 it is comes second half of the table, 7.5 also in between 6 and 7, and here 7 also in between 6 and 8 only you will get. So if it is nearer to xn, the values are nearer to xn, then you have to apply Newton backward formula. Newton backward formula. So here, suppose in extra, here these values are interpolation because x ranges from 0 to x0 to xn only, in between x0 and xn. Suppose if they given extrapolation points, means f of minus 0.5 means you will get here, and f of minus 1 get here, f of minus 2, so it get here. So these values are, it is nearer to x0 only, so then you have to apply Newton forward formula. Next here, if here suppose if they given to find out f of 9, f of 10, f of 20, so here you will get, here you will get, so it is nearer to xn, so then you have to apply Newton backward formula. So remember, first condition is x should be equidistant. Equidistant means difference should be same, then only you can apply Newton forward or Newton backward formula. So here when you get Newton forward formula, the given to find the given values, it is nearer to x0 means then you have to apply Newton forward formula. Suppose if they give the given x values, to find the x values it is nearer to xn means then you have to apply Newton backward formula. So here take down the problem. Find y of 1.4 given the data, so here x and y values. So for 1 it is 10, and for 2 it is 26, and for 3 it is 58, and for 4 it is 112, and for 5 it is 194. So solution, here we have to find y at x is equal to 1.4 here. So this is your x value, right? So x value is x is equal to 1.4. Now here for 1 y equals f of x secondary, so 10, and here for 2 it is 26, and for 3 it is 58, and for 4 it is 112, and for 5 it is 194. First check it, x values are equidistant or not. Equidistant means difference should be same. 2 minus 1 you will get 1, 3 minus 2 you will get 1, 4 minus 3 you will get 1, 5 minus 4 you will get 1. So x values is equidistant. Now you can apply Newton forward or backward. Now which one you have to apply? You have to check it. Either you have to apply Newton forward formula or backward. So what they have to here, first find out the first half of the table, middle of the values or middle of the values. This is the middle of the value. So here what you have to find out, it is 1.4. So where it comes in between 1 and 2 you will get 1.4. So it is nearer to x naught. So you have to apply Newton forward formula. So you have to apply Newton forward formula means you have to construct the forward table. You have to construct the forward table. So delta y. I'll take delta y. So these two difference, 26 minus 10 we will get 16, and these two difference, 58 minus 26 you will get 32, and 112 minus 58 you will get 54, and here these two difference, 194 minus 112 you will get 82. Here second difference, delta square y. So these two difference, so what you get, 32 minus 16 you will get 16, and here 54 minus 32 you will get 22, and here 82 minus 54 will get 28. Here next difference, delta cube y. So these two difference, 22 minus 16 you will get 6, 28 minus 22 you will get 6, and what you get last here, delta to the power of 4y, it is 0. So now you have to apply Newton forward formula. So what is the formula here? So here we have Newton-Gregory in forward interpolation formula. So y equals f of x equals y naught plus r into delta y naught plus r into r minus 1 divided by 2 factorial into delta square y naught plus up to where you have to write here delta to the power of 4. So r into r minus 1 into r minus 2 divided by 3 factorial into delta cube y naught plus so on, because delta to the power of 4 y naught value is 0, so neglect that terms. So write down so on, where r equals x minus x naught divided by h. Now look at here, you have to find out y naught value. So that means here this is x naught, means corresponding value is also y naught. So this is y naught, and here you have to find out delta y naught. So this is your delta y naught value, and here this is your delta square y naught value, and here this is your delta cube y naught value, and delta to the power of 4 y naught value. Right. Now you have to find out r value. So how will you find out r value? R equals x minus x naught divided by h. H means here difference. What is the difference? Here in equidistant difference is 1. 2 minus 1, 1. 3 minus 2 will get 1. 4 minus 3 will get 1. 5 minus 4 will get 1. So h value is 1. So here y equals, here what is y naught value? So first you have to find out r value. X equals, what is r equals x here. X means here what do you have? X is equal to 1.4. So they given, so 1.4 minus x naught value. X naught value is 1 minus divided by h. H means equidistant difference. So x value difference is 1. So what do you get here? R equals 0.4. R equals 0.4. So here y equals f of x equals, what is x naught? X naught value here, look at the table. Y naught value is 10 plus r value is 0.4 into here delta y naught. Delta y naught value is, what do you get here? Delta y naught value is 16 plus here r value is 0.4 into r minus 1 means 0.4 minus 1 divided by 2 factorial into delta square y naught value. Delta square y naught value is 16 again here plus r value is 0.4 into r value is 0.4 minus 1 into 0.4 minus 2 divided by 3 factorial into what is delta cube y naught value. Delta cube y naught value is 6. Here y naught delta to the power of 4, y naught value not taken means that value is 0, so whole term become 0. So y equals f of x equals here 10 plus here 0.4 into 16 plus 0.4 into here we get minus 0.6 you will get divided by 2 into 16 plus 0.4 into 0.6 into 1 point minus 1.6 you get divided by 3 factorial means it is 6 into 6. So if you simplify you will get 14.864. So therefore y of 1.4 equals 14.864. So this is the required solution. So look at here, your answer is for 1.4 it is 14.864. This value is approximately correct or not. How will you check it? Means here 1.4 in between 1 and 2 and here 10 and 26. So answer should be in between 10 and 26 only. So how much you get? It is 14.864. So in between answer is there. So then approximately your answer is correct. If you get 9 or 27 then your answer is completely wrong. Remember that one.